let's talk about runout tolerances. So runout is a surface variation that occurs relative to an axis of rotation. So you can think of this, a runout as a common check that's done when you're using a lathe. So you chuck a cylindrical part in the lathe by hand, you spin it back and forth and see if the part is true or if it isn't true. Now, when we're inspecting parts to see if they're good or not, that's probably not good enough to do it in a lathe. We'd use a precision collet or chuck or typically V blocks to accomplish that. But what we're really doing, we've got a part with two diameters, right? 1, 2. We're going to grab one of them, spin it. We'll have an indicator. We'll set the indicator on the part, and as the part spins, we'll see what kind of surface variations there are relative to that axis of rotation. So runout tolerances define the amount of runout variation that is permitted on surfaces. Runout is probably most commonly used on cylindrical surfaces, but it's not always. Runout could be used on conical surfaces or spherical surfaces. They can be used on perpendicular. So the part like this, we're going to grab it here. We can check the runout of this front surface. So we chuck it, we put the indicator here, and we're going to move this way as we spin it around. It'll control the wobble of that front surface. Runout tolerances always require at least one datum reference. The datum reference, the primary, is always an axis because you have to know what you're spinning it about. So if you have a part with more than one diameter, it makes a difference as to which one you grab to check all the other features. So typically, the most important feature is the datum. So if it's a shaft of some kind, it'll typically be the bearing surface that'll be the datum from which everything else is measured. Runout tolerances are always done at regardless of feature size. There's no MMC allowed with the datum simulation. So all that means is that if this cylinder is datum A, the primary datum for a runout tolerance, you have to make full contact with that cylinder. So just think about a chuck jaw closing in on it or a collet jaw closing in on it. It would not be good enough to just have a cylinder of similar size and put it in there. It could wobble around. That's what a MMC modifier could do if we were using position. So let's chat a little bit about the datum references. So here I have a part with 3 diameters, datum A, datum B, and then the center diameter is what we're going to control with our runout. So in this case, I've got a circular runout, which is the single arrow. 10 thou is the variation allowed. So your indicator, when it's set up correctly, should always read less than 10 thou total indicator movement or full indicator movement. This A is our primary datum. So it just means that when we fixture this part, we're going to grab it right here or put it on a V block, however we do it, and we're going to spin it about the axis developed by this feature. We'll put our indicator here and check each individual area on the part because it's circular runout. Now, another common thing you're going to see with runout is what's called a multiple datum feature or a compound datum feature. So in the feature control frame, in the datum area, you'll see a letter, dash, another letter, and they're going to be in the same box, right? So you don't have a primary, secondary datum situation. You have two datums that function as one. So in this case, you would have to grab or put in V blocks both of these, and together they develop a single axis that goes straight through the part. So it really doesn't turn out to be two datums, it's two datums acting as one. So this is a fairly common thing you will see out there with runout tolerances. So while I'm here, I could talk a little bit about total runout. Total runout just has two arrows pointed up with a horizontal line in between them. What this means is that along with checking in this direction, right, you have to keep the indicator parallel to the axis. So you spin the part 360 degrees, and then you keep spinning it as you move this indicator straight across. What it gives you is a more highly controlled feature. So the tolerance zone isn't just each individual section, it's a cylinder instead of individual circles.